This is 10.4, and we are working on radicals or rational exponents. So the cubed root, maybe, the cubed root of 27 is really just 27 to the 1/3. And what that's saying is, can you break 27 into 3 equal multiplications and then figure out how big one of those multiplications is? So 27 is equal to 3 times 3 times 3. So this says we have 3 of the same multiplications, and our answer is going to include one of those. So the answer is 3. If I had the square root of 16, that's really just 16 to the 1/2. Can we split 16 into 2 equal multiplications? Yes. 4 times 4. And our answer is going to include one of those. Like that. Okay. So 81 to the 1/4. 81 would be 3 times 3 times 3 times 3. And we want one of those. So the answer is 3. 27 is 3 times 3 times 3. We want one of those. Okay. All right. Come on. Wrong button. Sorry. So here, this is 125 to the 1/3 over 8 to the 1/3. 25 is going to be 5 times 5 times 5. And 8 is 2 times 2 times 2. And I want one of each of those. So 5/2. Okay. So this is negative 27 to the 1/3 or negative 81 to the 1/4. And the placement of the negative is important here. A negative on the outside is just asking, what is the opposite of 3 times 3 times 3, right? I want 3 of them, where I only take 1. So the answer is just negative 3. Okay? And here, it wants to know what number times itself times itself times itself, and I take one of those is negative 81. Well, if I put negatives in there, or actually it's 3, negative 3, negative 3, negative 3. What is the 4th root of negative 81? Well, that doesn't exist. Negative 3 times negative 3 times negative 3 times negative 3 is a positive number. So you cannot take the 4th root of a negative and get a real number. Just like you can't square root a negative and get a real number. Okay? But what if the negative on this one was inside? Is negative 3 times negative 3 times negative 3 equal to negative 27? Yes. So if the denominator or the size of the root is odd, then you can have a negative on the inside. If the size of the root or the denominator is even, then you cannot have a negative on the inside. What about negative square root of 9? Does that exist? Yeah. That's just the opposite of the square root of 9, so that would just be negative 3. Okay. So what is 6 raised to the 1/2 squared? So we have 2 copies of this, which means we multiply those together. So 6 to the 1/2 squared is the same thing as 6 to the first, which is just 6. So B, if we want the power of a power rule to hold true, which of these values should we define 6 of the 1/2 to be? That is the square root of 6. Okay. So here, I want to break 9 into 2 equal multiplications. So is it possible to write 9 by placing the same number in there? Yes. 3 and 3. And then this number tells me how many of those will be in my answer. And in this case, I only have 2, but I need 3. So I take another 3 and add it in, and I get 27. So 9 to the 3/2 is 27. What if I did 81 to the 3/4? Can 81 be broken into 4 equal multiplications? Yes. 3 times 3 times 3 times 3. How many of those will be in my answer? 3 of them. So the answer here is 27. So what about 4 to the 5/2? Can 4 be split into 2 equal multiplications? Yes. 2 times 2. How many 2's will be in my answer? 5. Not 5, oops. Times 2 times 2 times 2. That would be 32. Okay. What about 64? Let's not do that one. Let's say 32 to the 3/5. Can 32 be written as 5 equal multiplications? Yes. 2 times 2 times 2 times 2 times 2. How many 2's will be in my answer? 3 of them. So the answer is 8. Does that make sense? Do you see how rational exponents work? All right. The 4th root of 11 square, or 11 to the 3rd. The root becomes your denominator, and the exponent becomes your numerator. So this would be 11 to the 3/4. See how that works? This is the denominator, and this is the numerator. Okay. All right. If I had x squared times x to the 3rd, if the bases match, we just add the exponents. That would be x to the 5th. So here I have u to the 4/5 times u to the 1/2. So I just need to add those together. And in order to add fractions, we need common denominators. I'll times this one by 2/2 and this one by 5/5. So I get u to the 8/10 times u to the 5/10. So I add the exponents, and I get u to the 13/10. Now, it doesn't ask you to here, but what if I wanted to convert that to radical form? That would be the 10th root of u to the 13th. And that's sort of the same as the 10th root of u all to the 13th. So whether you put that exponent on the inside or the outside, it technically matters in some cases, but as long as you're dealing with positive numbers, it's not going to make a difference. So should I put that on the inside or the outside? Technically, they're the same thing, except in some instances that aren't really going to be a problem here. Sometimes it's more advantageous to put it on the inside, and sometimes it's more advantageous to put it on the outside. But in this case, they're exactly the same result. Okay. So if I had x squared and I raised that to the third, that's like having 3 copies of x squared, which ends up being x to the 6th. So the relationship between these two numbers is a multiply. So the relationship between these two numbers is multiply. So 7 over 12 times 3 over 1 is 21 over 12, and I can pull out a 3, and I get 7 over 4. So the answer here is x to the 7 over 4. Okay. So what is this negative going to do? It's going to flip everything upside down. So 1 over 81, and we'll raise that to the 3 over 4. Okay. So is there a number that I can have 4 copies of that equals 1 over 81? That would be 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. And I want 3 of those in my answer, so 1 over 27. Okay. Here, 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. So I have 5 copies of 1/2, and my answer is going to include 4 of those. So I have 1/2 to the 4th, which is just 1 over 16. Oh, that's it. All right, get to work.